Welcome to CCNA Routing and Switching Essentials, Connecting Networks, Chapter 1. In this chapter, we're going to talk about how you design your networks so that they're scalable and reliable. And we'll look at some of the different ways Cisco shows you to design your networks in order to make them modular. Network requirements. When we look at our network designs, we really kind of break our networks into three different sizes. A small network, which is services to up to 200 devices. And that's actually for a small network, that's actually a pretty big network in many areas. A medium-sized network is for devices from 2 to 1,000, and that would be hosts of servers, wireless access devices, those types of items. And then large networks, which are 1,000 plus devices. We're going to look at how you design your network. Now, there's actually a certification, the Cisco Certified Design Associate, which is on level with the CCNA. It's actually a little bit above the CCNA. Most time you get your CCNA first, then do a CCDA. But it talks a great deal more about how you design networks so they are scalable, modular, and reliable. We're going to talk about each one of these blocks here in terms of our main sites and remote sites as we go through this chapter. When we build our network, so we're wanting to build our network so they're hierarchical. And by that, it means the network is broken into more manageable pieces. The best example of that would be your IP addressing scheme. We want a hierarchical addressing scheme so that when let's say we have a site in Chicago and a site in New York and a site in Atlanta. We have those three sites connected via an MPLS cloud, let's say. We want to be able to summarize to 1, 2, maybe 3 networks, all of the different networks that are at each of those different sites. If we design our IP addressing scheme in a hierarchical fashion, in a correct fashion, we will be able to do that. We'll be able to summarize so that we have 1 or 2 routes for each one of those entities. And we'll have to maintain several hundred routes in the route table. We also want to think about modular networks and how we can design those. So there are enterprise campus blocks. There's a service block. So if a new type of service comes out, we can replace or integrate that into our services block. The data center block, where we've got our SANs and we've got all of our storage, all of our virtualized machines, virtualized servers in those areas. That'd be our data center block. Our internet edge block, we'll talk about where we can connect to multiple ISPs. If you've got them in your network designed in a modular fashion, if you need to change out one of those blocks, you can do it, or upgrade one of those blocks without having to affect the entire network itself. Also, obviously, networks need to be resilient, especially in this day and age. Now that we run our phones across most of our IP networks, it is very important that we have 99.999% uptime so that we have access to our telephones and to our ability to get out of our buildings. And that's very important too when you think about how reliant upon technology even the simplest of businesses have become. Even a very small law firm, let's say they're doing such a small law firm that does housing, it does loan applications or mortgages. If they can't get to the software that allows them to create the paperwork to do that, that business is shut down. So it may only be a network of 5 computers and 1 server, but it's extremely important that that network is resilient so that it will be there and will function and the business can continue to work. And then flexible. How can we add services to a network and expand it? And here's an old flat switch network. Obviously, it's one large broadcast domain. If a broadcast goes out, it would go across the entire thing. We can break this into a hierarchical network where we have a core distribution access layer. The access layer provides workgroup access, so access for each individual host. The distribution layer provides our policy-based controls. We're going to go into these in more detail in the next slide. And then our core layer is just fast transport at the core. Now, obviously, the big difference here is, as you look at this network, this is much cheaper. This flat switch network is much cheaper than our hierarchical network. Now we've got 5 multi-layer switches. We've got redundant links across each one of these, so we have resiliency. And you notice here that the way they've designed this network is that each individual device has a link to every one of the distribution layer switches. So it has an extreme level of redundancy. You might have actually been able to get away with just a connection to 2 of the different distribution layer switches. But it's important to note, as we build a network that is more resilient, as we build a network that has more redundant paths, those networks are much more expensive. Here we have multi-building enterprise network design where we've got an access layer in each building. Then each building, those access layer switches connect to the distribution layer and then that distribution layer connects back to a core, and then typically the core is where you're going to find your service blocks that we have on the network itself. So here we have our access layer. That's down here at the bottom. So you'll see that we have layer 2 switching. It is high availability, so that we need to be able to get access to those ports. Port security, individual ports will be secured so that only the devices that are allowed will be connected. Quality of service marking has to take place at these boundaries. There has to be a trust boundary here, so that IP traffic out here on these access layer switches is marked with the correct QoS. ARP inspection, if you have VACLs or VLAN access controls, you can do those out here at the access layer. Spanning tree and PoE. PoE is very important and has been talked about in previous courses, but you need to make sure if you need power over Ethernet to power these access points or these IP phones, your access layer switches have been purchased with the ability to do PoE. The distribution layer is aggregation of LAN or WAN links. It's policy-based security with ACLs. So we're getting now into filtering at layer 3. Routing services between VLANs. We've got redundancy and load balancing. Here's where you could have possibly your first hop redundancy protocols for the different VLANs. We got route aggregation, broadcast control, because each one of these will have VLANs. It will have policies based upon those VLANs for access control. And then we have our core layer, which is all about speed. It's all about speed and reliability, fault tolerance, scaling. You don't want to do CPU intensive packet inspection. You want all of that taking place at a lower level so that once you get to the core, it's just all about wide open speed. This will be a port channel or an ether channel that's going across this between these two cores. Now this is probably more realistic of what we'll see in the real world for many small and medium businesses, and that is a collapsed core. It's where you do not have a defined core in distribution, but you have a core distribution collapsed core, which for biggest reason is funding. It's much cheaper to do this than it is to have a full 3-layer modeled network. So here we have again our modular designs. We have a campus block, a data center block, branch sites, and teleworkers. Each one of these are further defined as we move forward into kind of enterprise architectures. So we're going to look at our access distribution, which is how we get onto the network. Distribution gives you access to this core, which is connected to our services block, lightweight access protocols, wireless connectivity. Our data center, which is going to have our Cisco UCSs or whatever virtualization server platform we're using, VMware, Hyper-V on that, and then also our storage and networks. Possibly inside of this data center is where you would find the Cisco Nexus line of products, their data center switches. And then our enterprise edge, which gets into our different modules in terms of how we connect out to the internet itself. And that's really where we go with this, and that is the Cisco Enterprise Architectural Model. Here's our enterprise campus. So here's building access or access layers, building distribution, just like the previous slide where these would connect back to the campus core. We would then have a server farm and data center locally, and that would be our local SAN, local servers, and those items. You could have on the enterprise edge an e-commerce, which is where you would accept incoming e-commerce to your business so that you can provide services for folks who want to buy items from you. Internet connectivity, which could be dual homed. In other words, it could be through multiple ISPs. Actually, if you are going to do a dual homed connectivity, it is very important that you research who provides the ISPs you're using with their upstream connectivity. It would be bad that ISP A and ISP B were both actually serviced by a bigger ISP, and if that ISP above them went down, you would lose your internet, especially when you're paying for dual homed. In other words, two separate ISPs, and you're hoping and planning through your policies that if one goes down, you would have traffic available or the ability to move traffic through the second. You need to make sure these do not go through the same pipe upstream. Very important when you do that. PSTN is a very last minute backup, public service switch telephone network, or plain old telephone system, POTS. And then you could have a VPN or site-to-site. The WAN site-to-site could be an MPLS cloud, a managed MPLS cloud that you own, or it could be more likely an MPLS cloud that you're purchasing from an ISP. And that could go over to an enterprise data center, and that would be a data center that services multiple campuses for an enterprise. The idea behind this architecture is that if you build using this architecture, you can easily replace pieces. So if you need to upgrade the building access portion, you can just upgrade that portion, or building distribution, etc. The problem with this is it's a good framework to talk about. It's just not always the way we can build our networks in the real world. So again, the enterprise campus connects users within the campus, the server farm, and the enterprise edge. Okay, that's the main portion of that. So obviously each one of those has its own individual items for high availability, IP communication, multicast QoS, etc. The edge is where our e-commerce and our aggregate connections to the internet take place. Our DMZs, if we happen to have DMZs that allow you to connect to websites, those DMZs would be available there, and there'd be a Cisco ASA firewall or some type of firewall available to provide services for the DMZ. Remote access VPN, depending on how you do that within your environment. And then WAN links. So those are available. Our edge, obviously our ISPs, our managed services, the single home or dual home. Single home is if you have a single connection to an ISP, and obviously dual home, there's two or more connections to a single ISP, or multi-home, which is connection to two or more ISPs. It's best if you're going to do a dual home environment that you go ahead and make it multi-homed. There's no need to connect to the same ISP with two links if you're worried about having true redundancy on the outside. In an ideal world, you'd be dual multi-homed. So in other words, you would have two connections to each ISP, and each ISP would be completely separate. However, that's where you're starting to look at a large amount of money to connect. So obviously single homed is one. Dual homed is connection to the same ISP with two connections. One or two, there's different ways you can do it. And then you're getting into multi-homed, which is company A going to ISP1 and ISP2, and dual multi-homed, which is the ideal world, but is also the most expensive. So whenever you're designing networks, again, it's a trade-off. It's a trade-off between how much uptime am I absolutely required to have, and what's my policies? What are the policies? And if you can go to your financial CFO and your CEO and you can say, we cannot be down, period. For every minute we're down, we lose $1.2 million. If that's true, well then you better go with a dual multi-home system at least, and probably backup redundancy in case of those going down. And that's the kind of ways when we design networks, those are the kinds of things you need to think about during those designs. Then now here on the enterprise branch, extends applications to remote locations. You've got teleworkers. This is much more common now, and you have entire companies that are literally nothing more than teleworkers connecting to central resources. There's no central site per se that they go into each day. They may have a branch they can go to if they need to, but for the most part they work from home using high-speed internet connectivity. Again, these are drag and drop, so if you want to, you can go through and actually do these and do the different items so that you get an idea of what each one of these are. And it is a good idea during the time as you're going through these individual sections that you do this, and then just click on check results and you'll see whether or not you have successfully completed it. It's a good way to test your knowledge. There are also occasionally drag and drop items that you may find on certification tests. Now, what are some of the challenges that are coming up as far as our network designs? One is the bring your own device. Everyone has a phone, everyone has a tablet. That is one. Online collaboration, the need to collaborate anytime, anywhere. Skype for Business, Skype, WebEx, all of those items. Video communication, cloud computing is huge. Now we can buy cloud resources and deploy those resources very quickly, these virtualized resources. The other thing that's not mentioned here that's really starting to become big is the Internet of Everything, and it's going to be eventually where there are thousands and thousands of sensors that have an IP address on them and have to be accessible across the network. So that is going to greatly increase our IP address needs. It's also going to make it much more interesting in terms of how do we take all that data from these sensors and integrate it into a system that makes that information useful. So Cisco's looking at a borderless network architecture. In other words, no matter where you go, your identity follows you. Data center and virtualization architecture, that is huge. It's an entire course on its own. There's actually now a CCNA data center certification that looks at the Cisco UCS, looks at basic data center configuration of nexus and those items, and then collaboration architectures, which allow us to figure out how we're going to work together. So with a borderless network, what we're trying to do is that we must be able to connect anywhere at any time. Devices can use Cisco AnyConnect, so that regardless of where you're at, you're connected to the corporate resources that you need. So additionally, you have TrustSec, Motion, App Velocity. All these items are items that allow you to, again, move your identity and do other things such as manage the building energy, looking at motion where you're at, and your emails or your voice. Literally you could take your phone and say, okay, I'm leaving my cell phone. When I'm in the office, I want my IP phone in my office to ring, and then as soon as I mark as I'm out of the office, it immediately starts forwarding calls to my cell phone. Those types of items are part of this borderless network. And then here's a little bit of marketing fluff about some Cisco items. WebEx Social, WebEx Meeting, Cisco Jabber, telepresence. How do you do call control, messaging, delivery, those types of things. And then all of that is supported by NCS, network computing and storage. Those are the big items in the virtualization realm. Our network computing and storage resources that we need access to. And that really gets into data center virtualization, unified management, scalable network, unified computing. How do we build these networks that are in the cloud, so to speak? And how do we continue to roll out resources quickly and efficiently? It's a video you can watch if you inside the course itself as you're going through the course materials. And then again, single location, here's what happens to networks. Obviously they grow. I tell people all the time, if you have 10 computers today, you'll have 20 tomorrow, and within 6 months you'll have 30. And then next thing you know, you're going to have a site that is in another city, or you're going to purchase another company, or you may even have a site in a foreign country, such as in Osaka, Japan. And once that becomes part of it, you've got to have that scalable, flexible network so that you can build your network out. And if you use that, at least as a guiding principle, if you always think about core distribution and access layers, and then expand that into that enterprise modular model that Cisco describes in this chapter, as you do that, you can start to think about a network that is modular and scalable and reliable. It is definitely not, though, a science. It is definitely an art. You go and you look at the network, you figure out the needs of the network, you figure out the budget, and this is really where, as IT individuals, we need to not only just be IT gurus, we need to be individuals who can speak the language of the business. What is the return on investment? What is going to be mean time between failures? Why am I paying this much for these dual multi-homed connections to multiple ISPs? Tell me why. You give them the business reason for it, and many times you are able to then get the funding for it. So remember that. Remember, we're looking at a network that has a core distribution and access layer. It needs to be modular, scalable, and reliable. And most of all, it needs to fit the needs of the businesses that you're designing the network for.